We are the team Unstoppable Unicorns. Again, we back to the new idea and we brought a new project to implement. So here is my team Unstoppable Unicorns and myself, Yashwant VS Devang, currently pursuing in AIML department, GM University, Davangere. And here is my team. And first, I will introduce my friend Ganesh Chaitanya. He is also pursuing in AIML department, GM University, and my friend Rohit Sridhar Ladwam. He is also pursuing in AMA department, GM University. And at last, Vaibhav K. Kumbar. He is also pursuing in AMA department, GM University. So let's start without further ado. What is our code and what we bought a new project today. So let's discuss about what the code actually is and what is the background of the code that will discuss by my friend Vaibhav K. Kumbar. Please, Vaibhav, please explain it.
So thank you, Yashwant. As we all know that we have come across some of the videos before, and this is a new video where we will be discussing about operating system. I think everyone will be knowing OS course. So in this operating system, everyone will be knowing the concept of processes, resource allocation, deadlocks, etc. So here we have some set of code where it is used to test the stress, debugging, and educational purpose to understand the system behavior in extreme condition. Like how does our system behaves in extreme condition? Extreme condition basically refers as input of multiple processes. We know that our system can handle only one process at one time because resource will be limited. But in this code we will be explaining that if there are multiple processes and only one resource, how our system responds. So this is the main agenda of our code. Let's go through the code and let's see how our system behaves. So in this we have basically two operating system. We have taken code for Windows, we have taken code for Linux. So let's first basically we'll check the code. How does Windows response? Ashwant, please go and explain the Windows concept using this code.
So this is the code actually what we bought today. So this is the code what we are discussing now. So right now let's start with the code. So in this C, the line number include windows.h and include stdio.h. This is a header file as we know. So now let's move on with the line number 4. DWORD and API infinite work. Actually, this is the very important line. So infinite work, you can see infinite underscore work. So it means that actually it will learn the infinite loop, simulating a process or a thread that is constantly doing some work without termination. So this is what actually this line. So what do you mean by like DWORD means? It is actually a return type, which is a 32-bit unsigned integer in Windows programming, and WIN API, that is a calling convention used for Windows thread function, ensuring compatibility with Windows API. So that is infinite work. As I said, it is a completely constantly doing some work without any termination. And as I used while loop, that is while one, so that is an infinite loop. The functions enters an endless loop representing a workload that never finish. So this is what the while conditions we are using now. And return zero, this includes for completeness. And even though the loop is infinite, if the loop were terminate, the thread will the thread would return zero. So typically calling a successful execution. So this is what the actual code what we have seen in the line number 1 to 9. So let's move to the next line, that is no 11. Okay. So actually, as we see here in the line number 4, you can see LPVOID. So this is parameters as we are using, that is a type def defined in the Windows header as a void. And actually LPVOID stands for long pointer to void. LP means long pointer and VOID is a void function, and it is usually used for compatibility with Windows data type convention. And LP param, that is actually a parameter name. So LP prefix stands for long pointer. So this is what these two parameters we are using. So let's go to the line number 11. Okay. Okay, in the line number 11, so int main, that is a main functions. This marks to start of the program, as we know, that is a main function. And while, so the loop will run identifiably unless the program is terminated externally or an exist condition is added within the loop. The body of of this loop repeatedly executes the logic to create a child process. So this is what the actual while is processing now in this code. So and in the next line, that is line number 13, that is startup info SI, declaring a startup info structure. This is the structure we are using. So SI is a variable of a type, startup info. A structure is defined by the Windows API. This structure specify how the child process should be started. So, for example, Windows size or appearance. So in this startup info SI, so there is actually three major part. That is a CB. So that is the size of the structure, and that is a LP title. That is a title of a new process window, and also something new DW flags we are using. So that is flags to control certain behaviors. So this is what the three types we are using in SI. Okay, and in the next line, line number 14, process information PI. So declaring process information, that is a structure in the same startup info, same like process information also a structure. So and PI is a variable of a type process information, also defined by the Windows API, as I said in the startup info SI. These structures will hold the details about the created child process, such as H process, H thread, or DW processor, and DW thread ID. So on. This is what it holds the information while processing. Okay, this is what the process information SI states that. And in the line number 15, so here mentioned zero memory. So zero memory and ampersand SI comma size of SI. So SI here which stands for to zero. SI is implemented to initializing a zero. So the zero memory function sets all bytes of the SA structures to zero. This ensures that all the fields of SA are initialized with a default value, that is a zero. Okay, and it's a common practice in Windows API programming to avoid uninitialized data issues. So this is what the line number 15, zero memory indicates. And let's go with the si.cb is equal to size of si. To set CB, as I mentioned in the startup info SI, so CB is size of SI. As I mentioned before, the CB fields of the startup infrastructure must be set to size of the structure, that is size of SI. And this tells the create process functions how much memory of the startup info structure, ensuring compatibility between versions of Windows API. Okay, so this is what they actually mean. And in the line number 17, memory, that is a zero memory, that is ampersand pi and size of pi. So in the first two lines, we initialize the startup info for SI. So in the next line, zero memory for PI, that is a process information. So what does it actually mean? Similar to SI, the PA structure is initialized with a value 0 to ensure no uninitialized memory is accessed. Okay. So this is important because process informations will be populated by the create process functions with details about the newly created process. So this is what they actually mean, creation and the startup information. So of this, code. So in the next further lines will be what is happens in the next functions, and what is the next process of this code will be explained by friend, that is Vaibhav K. Kumbar. So this is my part of the code. This is what will happen in this code. So in the next further ado, Vaibhav will be explaining how the code will works in the next process. So thank you. This is my part. Thank you.
Yashwant. So let us move on to the line number 19. In the line number 19, you can see if block, right? Yes, my friend is highlighting. Thank you, Ashwin. So you can see that in the line number 19, if block. Inside, the purpose of this is to create a new process to run the program. We need a process where program is executed. That's why if block is used. So the parameters used in if blocks are mainly the null. Basically, before going to null, we can say that the create process. This is the name of the function where function is initialized, and the name of the function is given as create process. So basically the parameters which we are using inside are null. Null is an application name and it is unused since the command lines specify the program. It is in the state of unused. So after null you can see that child program.exe. This is the command line string indicating the program to execute. I said that a process is required where program is initialized. So the process name is child program where the program has been initialized. So remaining are these null false values. So these are used as default security attributes to handle inheritance. Inheritance, as we know, parent to child, some of the parameters are passed. So this is known as inheritance, where this is also used. So as my friend was saying about ampersand si ampersand pi, these are pass we are passing this ampersand si and pi here from the startup info and the process information, where my Ishwant explained in the above. So in the next line, we can see if the process create process, there is a function name, right? As I said, it is a function name. If the create process fails, there will be a message which is printed as create process failed with error. This is printed by using get last error. This is a predefined function which is inside the code. The create process failed with error. This printf function will be outputted when the process failed to execute. Okay, then coming to the line number 23 and 24, these are used to handle the cleanup. The purpose of these close handle PI H process and PI thread are used to clean up the handles, like closes the handles to create a process, and its primary thread to avoid resource lags. As we know, if one resource is not allocated to a particular process, there will be no run of the process. Hence this is used. And we can see that this infinite loops ends here. After this close handle, the main function repeat the creation of the process endlessly. The main aim, what I said before creating in the starting of this video, is to create n number of processes, and let's see how our system behaves when there are n number of processes. So this main function creates an n number of processes, and it is being ended here. So what we can mainly observe here is the program is continuously created in the program is continuously created in the create process. That is a function where program is infinitely created, and it will be executed in the child program dot exe. So when the this create process will be failed, there will be a message outputted as create process failed with error, where this shows that our system failed to allocate the resource for multiple processes. So Ashwin, can you just run this program? Let us see the output. What the output will be? Yes, thank you, Ishwant. So we can see an error message like create process failed with errors. So this indicates that the create process function, where which I have been explained in the code, could not allocate an executable file, that is child program. So this process is not could not locate the executable file which is in the child program. This happens because in Windows correspondence, the error message, the Windows is saying that the system cannot find the file specified, because there are multiple processes have been produced at a time, and there is only single process. Hence the issue arises. This error arises because of this create process trying to launch the file child program, but it does not exercise the specific path of the program where child program.exe is executed. Hence this error is arised. So finally, what the conclusion is that we try to see that we try to initialize multiple processes where how our system behaves, but we can see that our system only allocates one resources only for one process at a time. So we can conclude that our system cannot handle multiple processor or multiple processes or infinite processes. Only one processes can be handled at a time. So this is the conclusion of this code, where we have gone through to create new processes running in a child program.exe, but it fails with error code 2 because the system cannot find the file specified. So the conclusion is multiple processes cannot run with a single resources. So this is of Windows. Now let us see how does this code works for Linux. Over to Ganesh. Ganesh, please go through the code where we can run in Linux. Thank you.
Since both of my friends Vaibhav and Deshwant have explained you how the Windows version work, now I am going to explain how Linux version work. Okay, in the first four lines we have four libraries. In the first line we can see that stdio.h. It's a standard for input output functions. Okay. Next, in the second line, we have uni std.h provides fork system to create new process. I'm going to repeat it, fork system, fork function, which is going to create new processes. Then in the third line, we have sys slash types.h defines data types used in process management. This which is used only for defining the data types used in process management. Okay, then in fourth line we have stdlib.h provides function like exit. Then coming to line number 6, we can see there is a function created named infinite work, in which a while loop is created, which is infinite, which is going to run infinitely, and which is going to execute. This process is going to execute continuously and indefinitely in this function. Any process which enters this function is going to run indefinitely and continuously. Then coming to the line number 12, a main function is created. In main function, we again have a infinite loop. In infinite loop, we have process identifier T. This process identifier T is a data type which is used for process identifying, in which uh, we are going to initialize PID for fork. Okay. Further, if loop and else if and else if will be explained by my friend Rohit Ladva.
Thank you, Ganesh. And from the line number 15, here we can see that if PID, which means process identifier, is less than 0, which is a negative value, it indicates an error. So, what is that error? For example, the error might be any insufficient resource in the OS. Here in this code, the error is preparer fork failed. So, if else is execute if a statement is executed, then this fork failed message is printed with the exit statement. Coming to the line number 18, here we can see that if fork returns 0, it means that the current process is a child. And the child process calls the infinity loop in the line number 19. This enters into an infinity loop and never terminates. So why does this never terminate and enters into a infinite loop? As there is no break statement in that part, that loop or the process will never terminate and will always be executing in that loop. And each iteration of the loop creates a new child process, leading to a rapid increase in the process count. So, what is the conclusion of this code? The conclusion of this code is that the code creates an infinite number of child processes, each running in an infinite loop, leading to rapid system resource exhaustion and potential system failure. So, this was the part which was explained by me. Thank you.
Okay, thank you so much, Rohit, for your beautiful explanation, and also thank you, Ganesh. Both of you explain about how the Linux program will work accordingly. So thank you so much once again. And the overall conversation and the conclusion of our code and of our new project will be explained by Mr. Vaibhav K. Kumbar. Please, Vaibhav, over to you. Explain how the Linux and the Windows operating systems will work in our new project. Over to you.
Sure, Yashwant. So coming to the Windows experiment, the program repeatedly creates these child processes using the function name create process. We saw a function name create process where different types of child processes are created in this function. So each child processes executing an infinite loop. Each child processes has been given in an infinite loop, so that infinite number of processes will arises. This continued process certaination can lead to significant resource consumption, and the child process occupies CPU memory without termination. There will be no end at all. So if the child program.exe is missing or not found in the create process, so there will be an error occurring, and this error will be printed as this file could not be found error 2. So this highlights the importance of the proper file location where the file has been saved, or the system resource management, that the system is having particular of amount of resources to a particular amount of processes. So in this scenario where executable file is not found or system resources are exhausted, this exhausted mainly refers as the system fails to allocate the particular amount of resources to the all the processes which are being provided by the infinite loop, that is infinite processes. Here in the Windows part, the system fails to provide an particular resources for the all the processes. So coming to the Linux experiment, in the Linux we saw the fork system calls creates or child processes that is run in infinite loop. This also consumes CPU and memory resources indefinitely. There will be no limit for it. It consumes the CPU or the resources indefinitely. So each child processor spanned by the fork perform continuous work without even terminating. As with the Windows example, this Linux is also uncontrolled processor. Uncontrolled process, or we can say it has exhausted, where uh, system fails to allocate particular amount of resources to the processes. So in the infinite loops, each child process prevent the system for reclaiming these resources, which emphasizes the needful for the careful management of the process termination maintenance system, in particular operating system or anything. So in the both experiment, it demonstrates the potential risk of the resource exhaustion and the importance of managing system resources effectively. What the code shows us this? A particular amount of process should be allocated with a particular amount of resources. If there is infinite amount of processes, there will be no infinite amount of resource to be allocated to each process. Here the system fails to allocate the resources, and the system goes in the position of exhaustible or unstable process. So the conclusion is, the system, if there are n number of processes, the system goes in exhaustible state, or n this one infinite loop state, where it cannot be continued further. So thank you. This was the conclusion.
Yeah, okay. Thank you, Vaibhav, for your conclusion. So now I want to thank everyone for your beautiful presentation of your code, Linux and Windows. Now in this video, I want to thank for ma'am, Shivaranjini ma'am, who is working in GM University as a assistant professor in AML department. Thank you so much, ma'am, for giving this opportunity to represent our new project about how the code will work in Linux and Windows. Thank you so much, ma'am. Thank you, and everyone. So, in this video, I want to thank for especially in my team, Unstoppable Unicorns. Thank you so much, everyone, for you all gave a beautiful presentation. And stay tuned for our upcoming new projects. Thank you so much. Thank you, everyone.